Hi everyone, I'm Josie from the Deps.dev team at Google, and we are working with Roger's team, Trust Fabric, to manage the pipeline that ingests data from all the certificate transparency logs. I worked with Roger to implement Sunlight or static CT support for Google's CT ingestion pipeline. I'm giving this talk to spark ideas on what Deps.dev can do with all this CT data that we have stored and indexed. And we definitely want to hear from you, so please feel free to grab me or anyone else from the Deps.dev team. Jesper's here, Eve is right there at the back. Feel free to grab any of us from Deps.dev after this session if you have your own use case for this data. So I mentioned that I'm on the Deps.dev team, and Deps.dev is working with Roger to house the CT data. But what is Deps.dev? So Deps.dev catalogs public data and metadata on supply chain artifacts, and in particular open source packages, with a focus on open source packages. We fetch, process, and then serve this data. Ultimately, Deps.dev helps you to understand, analyze, and make decisions about the open source dependencies that you use, are thinking about using, or might depend on without even knowing it. So here is a screenshot from the front page of our website. You can browse packages from NPM, Go, Maven, PyPI, NuGet, and Cargo. We track every package for each of these open source ecosystems. Before I get into it, just so we're on the same page, here we have a package that you've chosen to depend on. And it itself has dependencies, and some of those also have dependencies, and so on. So by trusting package A, you've implicitly taken on all of these other dependencies. So you might want to find out what's actually in them. You can search for a package on Deps.dev. In this case, I've searched for the npm package Express at version 4.16.4. This is the page that we show for that package version. And a few things I want to highlight. We show the security vulnerabilities known to affect this package version. We get the security vulnerability data from Deps.dev, and then we join that with our dependency data. So for Express 4.16.4, it has a couple of vulnerabilities, both in its package and its dependencies. These have, thankfully, all been fixed in the latest version of Express. We show the license of each package. In this case, we have the license of Express 4.16.4, which is the MIT license. And we also show dependency license. So for the dependencies of Express 4.16.4, most of them also have the MIT license, but a couple of them have the ISC or BSD license. So if you're using this package, you might want to check that those two licenses are also compatible with your project's policy. We show the number of dependencies and dependents of this package as well. We break that down by direct and indirect ones. The last thing I wanted to highlight is that we give the ability to visualize the dependencies of each package. So earlier I showed you a representation of a package and its dependencies, but in real packages, it's often much more complicated than that. So this is what Deps.dev got when we resolved Express 4.16.4's dependencies. The colored dot in the middle is Express, and all of the other nodes are dependencies of Express. And because dependencies have dependencies, this is visualized as a graph. You can also filter this graph for specific things, like in this case, we have filtering for nodes with a security vulnerability. This data isn't just available on the website, Deps.dev, although it does make for good slides. It's also available on BigQuery through our BigQuery dataset and our API. Our API is completely free. So what we do at Deps.dev is we aggregate and analyze open source data and make it accessible and useful. We fetch this data from many different sources, process that data by abstracting away different ecosystem idiosyncrasies. We compute insights on them. We might join that data together, and then we finally publish it through the ways that I mentioned earlier. I've mentioned package data a bit so far, but we're also processing and serving vulnerability data. We've been ingesting SigStore and Record data, and we're excited to be working with CT data too. As a team, we're new to the CT ecosystem, and we're not CT experts yet. Our expertise has been in ingesting and serving open source package data. So we want to hear from you about how we can make this CT data useful to you. What can Deps.dev do for the CT community? We're definitely not the only group looking at CT data. There's already lots of really good work happening in this space. And we're wanting to collaborate, support, and supplement. What needs and requests do you have that aren't currently being met? or maybe what you want already exists, but it's helpful for you to have more than one project providing the same service. We're hoping to do something similar to what we've done with package metadata. The package managers themselves, like NPM, PyPI, and Maven themselves have data, and we process it to make it easier to hold and use. Similarly, in CT, the logs already have the data, and we're hoping to do the processing to make that data easier to hold and use. I've brainstormed some ideas in the next few slides, but they are by no means exhaustive. So yes, please come and talk to us if you have your own use case for this data. This is just to get the discussion started. Some ideas that we had for what Deps.dev could do for domain owners. Deps.dev could be another service that lists certificates per domain, maybe through our free API. This could be helpful at the point when registering a domain to check that the SSL certificate hasn't outlived the domain expiry, which might help to prevent bygone SSL attacks. It's also the data that domain owners would need to construct alerting for certificates, mainly to detect certificates issued without their knowledge. We could also implement some kind of outlier detection through time series analysis. So in other words, we figure out what normal activity looks like for this particular domain. Perhaps you use a specific domain registry, or you always renew your certificate 30 or 90 days before expiry. And once we figure out what normal activity looks like, we can figure out what abnormal activity looks like, and that might help to reduce noise on new certificate alerts. We could also provide phishing domain analysis. So for a given domain, tell me if there is a potential phishing domain for this domain, maybe through edit distance to start off, and then we can expand to more sophisticated methods. For log owners, we could provide statistics like uptime, which user agents trust each log, latest STH that we observed. We could also provide statistics specific to capacity planning, like certificate throughput, how many certificates have been submitted to each log, but also how many certificates are unsubmitted to each log as well. So in other words, given a log, this is the number of certificates that were submitted to a different log in the time frame that the log has been up, but weren't submitted to this particular log. It would be good for the operator to prepare for that capacity, as running out of disk space can cause corrupted data. We could also provide statistics on progress towards static CT adoption. For example, how many certificates submitted in the last month, say, exist in a static CT log. For a user agent, we could provide statistics on log criticality. We provide the data that the user agent then combines with their data to figure out what percentage of HTTP connections would break if they were to distrust a specific log. So for many reasons, a user agent may need to just distrust a log before the expected date, and it's good to get an estimate of how many connections would break before enforcing that decision. For open source package ecosystems, we could use CT data to get insights into the URLs listed in the package metadata. So that could be a homepage or a documentation page. These are often unverified by the registries and are close to being free text fields. So we could check whether a valid certificate exists for that domain and whether that domain is expired. If it is expired, that could be a signal into whether the package is still being maintained. Deps.dev tracks a few million repos on GitHub, so we could do some interesting analysis by combining CT data with the code observed on GitHub. For example, we could detect when people are pinning certificates or pinning issuer keys. We have been working to make our other transparency data that we ingest recall available to academics, so we could do the same for CT data. And let us know, what can Deps.dev do for you? Are there any indexes on CT data that you would like, specific access patterns, use cases you would like solved? Letting us know tells us where to focus our efforts. Thank you.